So if we are given a function f of several variables, then the gradient of f is the vector of first partial derivative. So it's written with an upside down triangle like this. So it's the partial of f with respect to its first input variable, and then second input variable, and so on and so forth, all the way to the end. Sometimes it's also written grad f, like that. Now this symbol here, this operator, is sometimes called the del operator. And you can think of it as just being the derivatives without the actual function f. And it will be useful to use this construct later in chapter 17. We don't need to use it too much for right here. But the idea is that if you've got a function which is so a scalar valued function on Rn, okay, f, that's what we start with, and then you apply this del operator to get the gradient, then notice that the output of the gradient here, this is a vector of the same length as the number of variables in f. So that means we've got a vector field. So this attaches a vector of length n to every point of Rn. Okay, and so it's a very important vector field, and it has lots of interesting properties, and we'll explore those in the upcoming sections. For right now, let's just look at how to compute the gradient, and we'll just do it for a function of two variables. So suppose f is 2x squared y cubed minus x sine y plus x. Okay, then the gradient of f is going to be, so now I'm going to look at the partial derivative of f with respect to x, and I get 4x y cubed minus sine y plus 1. And then I'm going to look at the, so that was the partial of f with respect to x. And then I'm going to look at the partial of f with respect to y. So that'll give me 6x squared y squared minus x cosine y. So this one is df dy. Okay. And so you can see that this is, in general, this vector grad f is a function. So for any point in R2 here, you can see that the gradient of f evaluated at A is a vector. So it's another point of R2.